Please welcome Alex Daubois.
Thanks. Does this work? Maybe. Oh yeah, I need to. Oh, I think I'm going to talk very loud. So, all right. So thank you very much for attending this talk. You made the right choice. So we are going to talk about security breaches and how those kind of things can be exploited and what they are actually, really concretely, what those security breaches are in the PHP code. So first, let me introduce myself. I'm Alexandre Daubois. I'm the CTO of Letiol.com, a French company creating many web applications and so on, and also maintain a few OSS projects I'm going to talk about just after that. I'm part of the Symfony core team, also part of the Franken PHP core team, and recently I joined the team of maintainer of PHP. So yeah, pushing a few pull requests here and there, and having also some RFC accepted. So pretty happy of this year. So as I told you, I'm working at Letiol.com, and we maintain open source projects such as Symfony, API platform, Franken PHP, the PHP interpreter. So here, who is using Symfony daily? Okay, and API platform, maybe? Okay, a few. And Franken PHP. All right, you should use it. I'm not going to ask about the PHP interpreter, of course, but we have a few people at Letiol that are maintaining this. So myself, of course, but also Kevin Douglas, that you may know. And we have Antoine Boucher that is maintaining API platform and so on. So OSS projects are really our core business, actually. And PHP is our expertise. So, of course, we maintain also a few other projects, but clearly our expertise is PHP, and that's why I want to talk about PHP today. So a little throwback about PHP. So it was first released in 1994, released for the first time, and in the year 2000, the Zend Engine 1.0 was released with some huge perf improvements. Then 4 years later, Zend Engine 2.0 was released, and then that was the first time that we were able to do some object-oriented programming in PHP, which wasn't the case before. You had to just do some functional programming and so on. But then in 2004, you can finally use classes, objects, methods, and so on. In 2020, we have the just-in-time compiler that is introduced, which allows to bring amazing performances to applications that are CPU-intensive, heavy math, and so on. And in 2025, we have PHP 8.5 that is released, and PHP 8.6 is scheduled to be released in November 2026. Why am I showing you this? It's that PHP is 30 years old and counting, and it's still being developed, and it's still evolving. Thanks to the PHP Foundation, for the past few years, there are now core developers that are paid to fully work on the PHP interpreter, which is a big relief for the PHP engine. And yeah, the language is evolving super quickly, and that's really great news. So PHP is not dead, of course. So yeah, maybe you already saw this page. This is the source code of the PHP interpreter. And there are more than 145,000 commits for the last 30 years. So it's huge, of course, since the beginning. Is that it's like 4,800 commits per year. So it's pretty huge. It's also 13 commits per day, or an average time between two commits of 2 hours. So it's evolving quickly, and it's not just non-stop. There are new commits that are pushed to improve performances, bring new features, fix bugs, and so on. So the project is more alive than ever. And this is thanks to more than 1,000 unique contributors. And it also has nearly 40,000 stars on GitHub. So yeah, these are just numbers, but it shows you that this project still has a lot of interest. I'm sure that you are all agreeing with this, of course, in this room. But for the times I showed this presentation to some conferences that were not PHP focused, that's good to remind. And of course, PHP is powering between 75 to 80% of the web, thanks to WordPress, of course. But yeah, really, this is huge. And of course, whenever someone wants to create a new e-shop or personal blog or things like that, they are going to use WordPress. This is the solution by default. And this is why PHP powers that much of the web. And as you can imagine, with a surface of attack of this large, security is the main focus. And this is the most important, yet most complicated topic in tech projects, of course. So yeah, this is really a big deal. So this is the page of the security advisories of the PHP source. So as you can see, there are many security advisories that were published. So these are not the advisories of the 30 years of PHP, but we can see that we have some security advisories with some that are pretty recent, like the very last one, July 3rd of 2025. So people are still discovering security breaches in PHP, and people are still fixing them. So this is great. And as you can see at the right of the screen, we have like a score. So here we have moderate and low, and this is calculated thanks to the CVSS, the Common Vulnerability Scoring System. So this is a scoring system that gives you like how bad is the security breach that you are dealing with. And there are a few factors that are determining the score that you are going to have for a breach. So we have 8 of them. First one is attack vector. Does this breach can be exploited through the network, or do you have to have access to some physical device or so on? Attack complexity. Is it complex to exploit this, or is it super easy and nobody with no prior knowledge can use this security vulnerability? Third one is privilege required. Of course, if breach requires you to be like logged as an admin, it would be a bit less worse than if anybody can use it when being anonymous or things like that. User interaction. This means that does your breach needs someone to do something on their behalf, or can the breach can be just used without anyone doing anything on their computer, for example? The scope. Does the breach affect everything in your project or just a little part? Confidentiality. Does the breach is already well known by everybody, or is it not known at all for now? And of course, if nobody knows about it, it's less worse. Integrity. Does this break or compromise some of your data? Because remember that this scoring system is about all type of tools and projects. It's not just about PHP. So PHP is a language. So for the integrity, it's not really relevant. But for any other tool or library or things like that, that can be really relevant. And finally, the availability. So if your security breach is available in every version of PHP, for example, this is really bad. But if it's only on the latest versions or an old version that is nearly not maintained, etc., this is less bad, of course. And thanks to those factors, you can determine a score. And so this is a unique ID that is generated when you have answered every factor that I just showed you. Really, okay, it looks like a bit complicated, but really it's just all the answers compacted in just one string. So the first one you have CVSS 3.1. This is a version of the scoring system, and then AVN. So AV is attack vector and network, for example, in this case. And then you repeat the same thing for each factor, and then you have not a unique, but a string that is compact and have all the information that you need for the scoring system. And once you have this, you can determine the scale. So if it's 0, there is no vulnerability, of course. 0 to 3.9 is low, then moderate, then high, then critical or exceptional. Most of the time, you are going to see moderate and low security advisories. Of course, if it's critical or exceptional, well, it is exceptional, so we never see them, literally. Sometimes it happened, like the time where there were some breach in the XZ library or tool that we saw like 2 or 3 years ago, something like that. This is critical and exceptional because it's widely available, and it can be a backdoor and super easy to use. So yeah, that was critical or exceptional, but we saw in the security advisory page of the PHP interpreter that it's often low or moderate, but that doesn't mean that this is not bad, and we are going to see this. So for this, I want to show you how do they really look like, the security weaknesses, because we all hear about security weaknesses and so on, and vulnerabilities and backdoors and so on, but we don't always know what they look like really and how they can be exploited, why the code is vulnerable, what makes a code vulnerable. So for the first example, I'm going to talk about CVE 2025 1220. So null byte termination in host names. So this is a real security advisory of the PHP interpreter that was disclosed last year in July, I think, or June. Anyway, it was last year, so pretty recent. And it was about opening a socket in PHP with built-in function fsockopen. And we are going to see exactly what is this vulnerability. So what you have to know is that in the PHP interpreter, sometimes PHP is just a C wrapper. So for many low-level functions, or system functions or things like that, the PHP interpreter actually just wraps a C function, just registering it as a PHP function, telling, okay, this is available in the language. But actually, nearly what it does is just, call the underlying C function, and that's it. So you have the PHP function, fsockopen in this case, wrapper in the PHP interpreter that just registers this function and then calls the underlying C function. And it makes, of course, a few verification about the arguments that you are going to provide, if it's a string, if it's an integer, and things like that. And in this precise case of CVE, the problems lies in the underlying C function. Well, not exactly. It's not the C function that is vulnerable, but we are going to see what I'm talking about. So for that, I just want to remind how strings are managed in C. So string management in C, you really deal with pointers. I mean that when you are dealing with strings in C, you are telling the C language, okay, I have a pointer to this memory address. And when you want to store, for example, hello in C, it requires 6 memory blocks. So 1 for each letter, and then 1 final memory block to put the null byte string. And this is what is going to tell the C language that this is the end of the string. Because you are not dealing with just an abstract string like in PHP, for example. It's really, you are dealing with memory blocks. And when you have just memory blocks, you have to determine something that says, okay, this is the end of the string. And the convention is that we use the null bytes. So you have something like that. You have the whole memory, so like 1 gigabyte of memory, and then you have your string pointer at the first line, at the first letter. And if you want to read the second letter, you are just going to increment the string pointer because memory addresses are just integers. So you have the string pointer, +1, it's a E, +1 L, and when to stop, whenever we encounter the null byte termination, we know that this is the end of the string. And this is a convention that all C developers and C++ and so on know and adapt. And every functions in the C language are using this convention. The null byte is what tells you this is the end of the string and you should not read after that. Because if you try to read some memory that you are not allowed to read because it's after the null byte, then you are going to have a seg fault, or just your program is going to crash, or this is an undefined behavior. So you don't want to do this. Of course, you don't want your program to crash. And in the case of this CVE, that was a huge problem because in PHP, you're like, okay, I'm currently manipulating a string, just a string, and don't have to care about memory blocks and so on. But in C, I'm currently manipulating a pointer. So there is a slight difference between those two that makes the vulnerability. because actually you have the wrapper in the PHP interpreter that deals with strings, and it calls the underlying C function that relies on null bytes. But in PHP, you are allowed to have the null byte in the string. That's completely allowed. You can do whatever you want. But in C, you can't. And this is a slight difference that makes this vulnerability exist. So this looks like this. We have fsoc open. We want to open a socket to an address and write something in this, and then close the socket. But you can see that we have a null byte just after localhost. And this is allowed in PHP. You are allowed to have null bytes in PHP strings, but not in C. So what really happens here, and this is what I want to show you live. So I'm going to change just a setting. Okay, it doesn't crash, so it's maybe a bit really small, like this. It's okay? Yeah, fine. All right. So let's say you have a Docker file with a basic setup. So I chose 8.3.22 because this is the latest version of PHP that is affected by this breach, of course. So we have this Docker file that we are going to run right now. Yeah, like this. Okay. So we have a Docker with PHP that is running inside. And what I want to do as well in the setup is create a secret service inside the Docker, like this. So we are going to have another service, which is a PHP server that listens on this port with a few files, but that's it. But it's just an internal service of the container, so you are not able to access it from the outside. Okay, like this. Right, the setup is complete. We have PHP that is accessible from the outside and a secret service in the container, which is not accessible from the outside. And then we are going to have a look at this. So I'm going to run the first query. So, oh no, just want, of course, to show you the PHP file first. So in the PHP file, what we are going to do is, okay, we have a host and a file in the query parameters, for example, and we want to ensure that the file and the host that we are going to fetch, thanks to this script, the host ends with securedpartner.com. So we are sure that we are gathering the file from our secured partner. And if we can't, then unauthorized domain, and we stop here. If the host in the query param ends with secured partner, then we can continue. And we are going to try to read the file on the server. So here, we are going to open the socket, so fsoc open with the host, the ports, and some setup, etc. Error management, as usual. And whenever the socket is open, then we can craft our HTTP request to gather the file that we want to fetch. So we have the HTTP request, we want to get the file, and we write it to the socket. And whenever we have a response here, we are going to get the response from our secured partner, close the socket, and then return the response. Okay? So this is just a simple script that says, I want, my application, I want it to get some file from our secured partner. And just like a man in the middle, actually, but with some checks like this. Okay. So, of course, if I'm going to execute this query, like this, unauthorized domain, of course, because we have the host here, which is just our local host, and the file, but the domain doesn't end with securedpartner.com. So, of course, it doesn't work. Now, let's try the second query here. So, the difference here is that, okay, the file is the same, but the host is the local host, some null bytes encoded in the URL, because this is also allowed, of course, and then we end with securedpartner.com. And then we get a file. And if we try to just run this, well, we have something special here. This is actually something that was inside the secret service that I created earlier. This is the API keys.json file. And it worked. But why? Because I have this. It ends with secured partner. So what happens here exactly is, okay, we get the host. We check that it ends with securedpartner.com. So it works, of course, because once again, null bytes are allowed in PHP strings. So yeah, this check pass. And then we try to read the file. And then we have the culprit here, which is fsockopen. As I told you, fsockopen was just a wrapper around the C function, which has the same name. But because the C function relies on the null bytes, what happens here is that it receives this, but the C function sees the null byte here. So it says, okay, this is the end of the string because this is a convention. So the whole part here is discarded. And what fsockopen is going to see is just that, the local host. And because this is inside the container, of course, I can access the secret service that I created earlier. Okay? So, yeah, this is the whole security breach here that you can see. It is because the fsockopen just discarded this because it's just a wrapper around the C function. And in C, the convention is that the null byte is the end of the string. All right. So let's change this again. Nice. Okay, so what we just did here is server-side request forgery. We created some requests on the server that wasn't supposed to be. As an example, for this CVE, the score was 5.9 out of 10. So it's a moderate security advisory. But it's not actually that moderate because it's bad. It allows to create some requests that you're not supposed to do and so on. So the first thing that I want to tell you is that maybe it's moderate, but that's maybe the problem because it's maybe not the right word. It's not critical, but it is impactful. So don't underestimate when you see a security advisory with some moderate or low severity. It may be impactful for you, actually. So language boundaries are attack surfaces, and PHP is memory safe, but C is not. And the boundary is where the bug was born, actually. And that was not necessarily old code that was not protected enough or things like that. It was just that it was a dangerous interface, actually. PHP strings are not C strings, and implicit assumption makes vulnerabilities. So yeah, as I said, vulnerabilities not always come from complex code, but sometimes from obvious code. Because that was not that complex, and that was pretty easy to fix, actually. But yeah, because that was maybe too obvious, then a vulnerability was born. And yeah, security audits should sometimes also include the runtime, so not just userland, not just frameworks, but also the engine itself. And auditing a PHP framework without understanding the engine it runs on might be incomplete in some cases. So yeah, it's important to understand how things work deeply and internally to really understand what you are looking at and what vulnerabilities can be discovered. All right, so that was the first vulnerability that I wanted to show you. And that was an example of a concrete vulnerability, how it looks, and how you can protect against this. Well, you can maybe just do better input sanitization and things like that. Better input validation, of course. Never trust something that the user is sending, always. So harden your validation rules and everything is going to be fine. All right, so the second breach I'm going to talk about is pretty different. And I'm going to talk about the zero-dm backdoor. So maybe some of you already know the story behind this, but I know that a lot of people ignore what happened actually in PHP a few years ago when the backdoor nearly made it to a PHP final release, because it made it to the final to the release candidate of a PHP version. And yeah, I wanted to talk about this one because it's about backdoor, and backdoors are frightening. And we always hear about it's super bad, we have a backdoor and so on. But what actually is a backdoor, how it looks like, and how people can actually exploit them. So everything begins with a commit in March 2021, which is skip CI. So this is a special tag for the PHP interpreter to just skip the CI when you just want to fix a typo and so on, and you don't want to run the full CI, of course. So this is the typo. Yeah. So this is not a typo, of course, and we are going to have a deeper look at this. I just want you to notice the file where it is added, so zlib.c. And that was pretty strategic because in every default installation of PHP, you have zlib, which is enabled by default. PHP relies on a full extension mechanism, and zlib is actually one of those extensions that is enabled by default in PHP because it allows to compress all the responses you are going to send back to the client and so on. So it is enabled in every installation by default, but this can be disabled. But Linux distribution like Debian, Ubuntu, and so on distributes PHP with this enabled by default. So everybody is concerned by this. And the thing that we showed that is obviously not a typo actually added some mechanism to have a look at this HTTP user agent with 2T. So PHP, when it receives the requests, automatically parses the HTTP request and all the headers, and is going to store all the headers into headers globals. A global variable in the PHP interpreter that has everything, all the HTTP headers and so on. So this is actually how PHP normalizes HTTP headers, HTTP underscore, and then the name of the header. So here, user agent, which is HTTP header to tell, okay, I'm sending a request from Safari, Firefox, Chrome, and so on. User agent, as usual. But there is a typo, and we are going to see why. So this is actually the typo that was introduced in the commit earlier, and we are going to have a look at it. So the first line is, you can see that we have HTTP globals on the first line. So this is the global array where all HTTP headers are stored by the PHP interpreter when it receives the request. And then we have Zend hash str find, which is, okay, in this hash map, find the element that has this key. All right, so in the HTTP globals variable array, we are going to have a look at a precise key, which is HTTP user agent with 2T, which means that we are going to check if there is an HTTP header called user-agent with double T. This is what the first line is doing. And then in the second line, we are going to check that the 0diom string is actually in the HTTP header. And this is important. And whenever we find this value in the header, then we can call the Zend eval string function. Basically, this function is like, okay, I'm going to give you this PHP script, just execute it, whatever it is. We evaluate the string just like the eval function in PHP, of course. So if we can resume, we have a look at HTTP globals. We find some special header, and if it contains a special value, then we can execute any PHP script that is given after this value. So I'm talking about 0diom for a few minutes now, but actually they are not related to this. It was just some troll or things like that from the hacker, just to make things a bit more complicated to understand from where it comes. But 0diom, which is a zero-day vulnerability marketplace, has nothing to do with this vulnerability. And we don't really have any more explanations about this. So this commit, how such commits can make it to the PHP source tree. this is the biggest question, of course. Well, the disturbing discovery is that the commit was created and pushed by Rasmus Lerdorf, which is no one other than the creator of PHP. So the creator of PHP pushed this. And it was reverted by Nikita Popov a few minutes or hours later. Nikita Popov, which is a big contributor of PHP. For example, he contributed the generators or this kind of features, big features. So that was one of the biggest contributors of the PHP engine. So the fixed typo was reverted by Nikita Popov before being reverted again by Nikita Popov. So we have the creator of PHP introducing a backdoor, then one of the biggest contributors reverting it before reverting the revert. And then finally, Levi Morrison reverted the revert. That reverted, yeah, you got it. Yeah, so you are like, what just happened? And also, that just happened in a few hours. It was not like in days or months or something like that. It was just in a few hours. And before I give you the answer of this mess, I want to show you the actual backdoor running. So let's change like this. All right. So in this second example, I have here an executable compromised. So if you ever receive some executable from me, okay, know that it's compromised, so don't push it to production, of course. So this is actually the version that was affected by this commit wasn't compilable anymore on my computer, at least. So I took the latest PHP 8.6 dev branch and I cherry-picked the commit and built another compromised PHP executable. So this is compromised. And okay, so we have a makefile. So yeah, just let's run it like this. Okay, so we have our compromised server that is running with the backdoor. So the index is just this, okay? Hello from index.php, and that's it. And now we have our request. So I'm just going to send the GET request to our server. And I have a special HTTP header here, a user agent with 2T, with 0 just like we saw earlier, and then some PHP scripts. And it can be really whatever you want. So here, of course, a call to system to have a few insights on what's happening on my own computer. Super useful, but you get it. You can put everything you want here. And of course, because this is compromised, if I run this, okay, so that's nice. I have hello from index.php, but also I have everything in my computer. So system, I went to Golang projects, pwd prints this, and then ls everything, and I have everything. So I can literally, just execute anything. And this is a real backdoor. Okay, so this is how it looks like, and anybody can actually use this if the PHP executable is compromised. And as you can see, I don't need to be logged in. I don't need any user interaction. Attack vector is super simple. So as you can imagine, such vulnerability would be critical exceptional, of course. But it's also, a bit hidden, because you have to know that you have to put a second T to user agent, which is super hidden. And you also have to put this prefix for it to work. So it's hidden in the PHP source code, and nobody is going to discover it by accident by doing some request to the PHP interpreter. All right, so that was, no, that's not it. Okay. So that was the demo of the backdoor. All right, so as you can see, it was super easy to use. And I want to remind you that PHP is powering 80% of the web. So imagine if this made it to some release and nobody saw it. It would be just catastrophic. So how did this happen? Why the creator of PHP and one of the biggest contributors would push something like this? Actually, it was not them. It was that the VCS server of PHP was compromised at this time. And as you know, Git doesn't do any verification about your identity. You can put everything you want in user.email or user.name configuration of Git, and there is no verification that it is your real name or things like that. So likely the hacker made it to the Git server of PHP and just used the name of Rasmus Lerber from Nikita. So yeah, sorry, but it was not a huge story where the creator of PHP wanted to sabotage his tool. But what you have to know is that it made it to the PHP 8.1 release candidate one. So it was not a dev branch, or it was not some alpha, beta, or things like that. It was a release candidate. So it was nearly ready to be distributed to the world and be packaged in all the repositories of Linux distributions such as Debian, Ubuntu, and so on. So you can imagine that it would have been pretty bad if it made it to the final release. Because of this incident, PHP maintainers and people that manage the whole PHP organization decided to switch to GitHub as the official repository host for PHP. Before that, it was just a mirror of git.php.net, but they were like, okay, it's too much of a burden to maintain our own VCS server, so let's just switch to GitHub, and then it won't be compromised as it was for our own server. So a few things to understand from that is that trust is not a security mechanism. It was made by reputable authors, even if it was not them, but reputable authors on reputable project. I mean, it was still compromised. It's not because, it's a big name that created a commit just to fix a typo, that it's a trust mechanism, a security mechanism. All right. So now we have GPG key and so on, but in this case, nothing was signed, and someone could have said, okay, this is big contributor, so I don't have to check anything. But actually, it's not a security mechanism. Your infrastructure is part of your threat model. So VCS, CI, release process, these are things that you must absolutely take into account when you are doing some security audits. It's not just, we have a VCS, we have our CI that do unit testing and so on. You have to think about it also as of part of your threat model, of course, always. Open source is not immune, but it is resilient, and it was detected, reverted, and publicly documented. And it would have not been possible if it was some proprietary code. So thanks to the open source, some people went through the commit and saw this, and they alerted the maintainers that something suspicious was being done. So we don't know exactly how they managed to enter the VCS, the version control system of PHP at the time, or it's not publicly documented for this part. But we know that this is exclusively because of open source. And this is why open source has such a huge reputation in security and why it is more resilient than proprietary code, because of this kind of thing that can happen. So language boundaries are attack surfaces. Data structures are not the same everywhere, so think of it. Sometimes it can be really useful. Security audits should include the runtime. Trust is not a security mechanism. Infra is part of your threat model, and open source is not immune, but it is resilient. That's it. I hope that you learned a few things about what are concretely security vulnerabilities, because we always hear about them and, it's bad, they've been hacked and so on, but we don't know exactly what it looks like. So maybe those are not super complicated, but it allows you to really understand from where it can come and how to protect yourself against them. So more input sanitation, validations and things like that. And of course, open source is super resilient and not immune once again, but this is why open source is so known for being super secure, because people from all over the world can just go through the commits and do some security audits on their own. And yeah, that's what makes its reputation. Thank you very much. If you want to follow me I have a blog and also some socials where I share a few things like that. So if you want to follow, this is where you can find all my links. And I'm really glad that you were here, and I hope that you learn things. Thank you.
Thank you, Alex. All right. So, complete failure on my part. Forgot to mention that we have a Slack. We have a channel for each room where you can ask the speaker questions. So, if you do have any questions for Alex, you're right to laugh at me, yeah. If you do have any questions for Alex, please join the Slack channel now. Join the Woolbrook channel and then ask them away, and I'll try and get to them as quickly as I can. In the meantime, Alex, I do have a couple of questions from myself. How are these vulnerabilities typically discovered?
Well, it really depends. But most of the time, all the open source projects have an email address where you can send security vulnerability reports. Of course, if you have discovered something, don't create an issue on GitHub to tell everyone that you discovered a backdoor, of course. But there is an email where people from the security team, so there are a few people in the foundation that are part of the security team of PHP, that reads these emails, and they acknowledge the report and then do some investigation and create the fix, and then warn everybody once the fix is found. So it would deserve a whole talk about it, but typically that's people that are sending email to specific email address. So Symfony also has such address, so security@symfony.com. PHP is like security@php.net, I guess. Everything is on the repo, so typically that's like this. And fuzzing also happens, but fuzzing it's more for like it detects segmentation faults or edge cases and so on. But fuzzing is not really the best way to discover security vulnerabilities. It can, but it's pretty random. So
Sense. Pauline wants to know, should the foundation have a bug bounty program considering the significance of PHP?
Maybe. I don't know.
Your opinion.
Saw the eyebrows go.
I would love to say yes, but the foundation is already always looking for funding and sponsors just to pay people to work on the PHP interpreter full-time or part-time. So it would be great, but I think that for now, this is not maybe the priority. We all know the financial situation of the whole world, actually. And the foundation is also part of this organization that lives thanks to sponsors. And so Volker and...
The foundation also allowed the German government to spend 150 grand on a security audit. This is why we had so many vulnerabilities in 2025, because money was given to people to report and find these, and then paying maintainers to fix them. So that is an alternative to a bug bounty program. It's taking money from organizations and doing security research with them.
Nice. I guess final question. Ollie wants to know, what happened with the revert of the revert? Was it a mistake?
It was not a mistake. It was actually the hacker that tried a second time to reintroduce the backdoor, but under another name. But it didn't work. But no, it was not a mistake. It was actually a second tentative to, sabotage the thing.
It's pretty gnarly, isn't it?
Yeah.
Go.
So Nikita found the vulnerability and reverted it, and then they reversed it back.
So the hacker introduced it, and the Nikita reverted it, and then the hacker took the name of Nikita, and pushed the revert of the revert.
Attention, please.
And
attention, please. The fire alarm is about to be tested.
Just in time.
All right, well, with that said, please give Alex another round of applause. Thank you very much.
Thank you.